The next talk. So the next talk are from Clemens Ott, and the title is The Future of IoT and Visual Programming.
Okay, this is Distance, ist dieser Abstand gut? Besser? Jetzt?
Ja, gut.
Good. Well, good evening. My name is Clemens Ott, and I am here to talk about a little idea that can grow very big. My original education is in mechanical engineering and environmental health. I went to the University of Texas. The speakers before me, they talked about visual interconnectivity and the need or the importance of simple user design. All of which can be accomplished easier when the programming is done by people that are closer to the users than normal programmers. And so I will take you on a little journey here for the next few minutes, and then please ask questions. Yes? As I was preparing myself for this talk, I was looking for the Internet of Things maturity, and found lots and lots and lots of examples. And only one of them had the user mentioned in some later mature state of that cycle. I want to say that the way we are going to deal in IoT with the user is going to be very important for the future of IoT. Are we going to put the user, are we going to encompass the user in the whole concept? And if so, to which degree? The user, I go even further, and you can separate the user in its use, in its private use, and business use. Now, on another level, the Internet of Things is nothing but a couple sensors that you connect together, and it's a network, nothing more. Originally, an embedded system, right? Like we have in cars, you know, you turn a turn signal or you step on the gas. Okay, and now it's based on an embedded system. It has a computer chip behind it. That is that changes a whole lot. For example, in a cockpit, talking about helicopters, an embedded system, for example, in an R-22, Robinson helicopter, allows the pilot to have a reaction time of 4 seconds rather than 1.1 if the engine fails, by simply turning on the throttle to keep the RPM at a certain range. That's all it does. It goes automatically, nothing happens. In the case that he lowers the collective in 4 seconds, he will be fine. Now, that's the classical embedded system. We are now looking with the Internet of Things, and here it starts to become a little bit interesting. We want to expose what is commonly known as an embedded system to the outside world. How do we do that? Well, Raspberry Pi was presented with a gateway, for example. Yeah. So the Internet of Things is driving that embedded domain in the direction of the server, the processes, and even the user. And it is quintessential that we encompass the user here, from my point of view. there are different driving factors. What drives the Internet of Things right now, I think, is the biggest industry in the world, the cars. They have determined that we want to do an Internet of Things thing. Why? Because Tesla and Google got into the car business. Naturally, they were not really car companies, so they decided they are not by nature car companies, and they started as software companies. And so they think, okay, we can do the car business. And as a matter of fact, VW and BMW, for example, they are now going in the same direction. Home security is another big issue because of the people are feeling insecure since September 11th and all those terrorists out there. If it's for sure, if it's for true or not, that's a different story. Germany came up with the Industry 4.0. They want to automate their industry even further. That altogether increases the omnipresence of Internet of Things with large hardware manufacturers and service providers. The point is still that the Internet of Things will bring the embedded realm to another abstraction level. What are the big movements outside IoT as I see it right now? Well, there's the mobile device. Everything gets smaller. Nobody is using PC anymore. Laptops are getting less and less. And tablets and mobiles are replacing pretty much most of the PC application. If this, then that is part of a concept or actually a service online that is in the realm of Internet of Services. That is why is that interesting? Because that's the first visual, programmable environment that is very close to the customer. And on the business side, processes are also very visual. The business process management realm did not deliver what they wanted or what they actually promised, so that was a failure actually. And the examples of the cockpits, airplanes and dashboards. Dashboards here, I mean dashboards not in cars, but dashboards in software. So, embedded domain, like was the classical, the Internet of Things is where we are now driving, and closer to the customer is the Internet of Services and the user at the end. The visual tool is on the personal side of the user, the wearable and the mobile device. On the business side, it is the Internet of Things, for example. On the next slide, I will show you, and on the next slide, I have a couple of examples. For example, LabVIEW is a visually programmable thing, like the Raspberry Pi, except it's 20 years old and is very mature. Node-RED is almost as visual as the LabVIEW. It has components that you can click together from the embedded domain over Internet of Things, over Internet of Services. It has a broad library of steps. The Bluemix from IBM is a tool that allows people to deploy server software easier and more scalable, and make it more scalable. The Odysseus project from Germany is a more or less visual tool that allows the the spooling and the treating of data and data streams, though it is programmed with code. Okay, here is my idea comes into the game, where you see to the right of the classical embedded domain, there is a big field of applications that have more or less visual programming languages. In order to get the user not only to use an interface, we have to give him a tool that he can use himself. Mainly, that means we have to give him a tool that he can program with. That means we have to have a language and an environment that allows the user or the person that doesn't know how to code to program not only the graphical user interface, but the algorithm layer and the data services, all through a visual interface. None of those, the LabVIEW, nor the Node-RED, nor the Raspberry Pi, has a visual programming language that includes the algorithm layer. And this is where we come into the game. We have worked on a solution for exactly this for the past few years. What we have created is just like the processes that were done in UML many years ago. We have been able to isolate the algorithm layer, the GUI layer, and the data service layer in a set of steps that you can program visually, connecting over the web service definition language or web services to any of the other services available. That is basically my talk. If you have any further questions, thank you very much.
So if I understood that last slide you showed, then you're taking care of everything above the server gateway. So one of the concerns that I have when I've been reading up on IoT is this lack of end-to-end manageability and usability. That picture seems to even promote that lack of end-to-end, because you're leaving the classic embedded domain, as you called it, alone, as it were. Correct. Is that deliberate?
No, correct. Why is that? Because I do think that the Internet of Things, yes, is, as the name says, has to have an Internet, at least, segment between the gateway and the service, or between the service and the user. Yeah. The programming in here is standardized by many years of standards that I don't even dare to rattle off by heart, because they are so complex. What they will do is, or what they can do, is to provide an interface here that you can hook into, stateless or stateful, depending on what you want to do, and then visually program whatever you want to do with those data, put it in a database, put it on a cell phone, send an email with it, and do that through the protocol of the internet or through the hardware layer of the internet, meaning through a physical server on the web. That is the reason why I'm breaking off here. Of course, there are sensors that you can talk to directly, but in general, there has to be some sort of a gateway here, because the production streets, for example, if I go in there with a visual programming tool from the net, from the web, hey, I do program our production street now from the web with diagrams, and we'll just call Clemens if something goes wrong. they are not going to play. They are not going to play. They are not going to go for that. I mean, they're not going to trust me for that. When they have millions of euros going down the production line every minute, something goes wrong, and 50 or 500,000 euros are down the drain. They're going to blame me. So no, we'll take the data from here and visually program it all the way over to the user through all those different devices or services. And I think that's also the Internet of Things. Please correct me if I'm wrong. Is the Internet of Things something that's on the Internet, or?
I think we could have a long semantic discussion.
Yeah, exactly. So
I think what's clear for me is that those number of users aren't going to grow at the same rate as the edge part of the network. So we're talking, reading all sorts of forecasts, 30, 40, 50 million elements in that edge of the network. How do you represent that visually to your user? I think that's going to be
through the gateway.
But each of those elements will still need managing.
You mean these ones?
Yeah. That's where I see the biggest growth, and I assume therefore a big challenge. Not an expert.
Correct. We could make the runtime environment of the programming, this programming environment comes with a runtime environment, we could put it in devices and have it locally executing. That we could do. But we are running in, our platform is written on Java. And at that level, those real-time devices use programming languages that have much less, they have a different garbage collection and a different lag time. So with a Java system to go in there, I don't know how realistic this is. I don't think so.
Could you show us an example of your tool?
Yeah, sure. Like I said, flowcharts. Well, I didn't. Activity diagrams start with a start, a step, a second step, and a third step. And here, in this diagram, we have abstracted at a certain abstraction level what the software is. There is a GUI layer, there's an algorithm layer, and there's a database or data service layer, let's say. It can be from a sensor, it can be from a database, it can be from anywhere. That's the structure that our language is based upon. And here, one more slide, an example. On the right side, you see the library that we have available here on this example. And this is actually a real software feature. The green step is a GUI. The purple ones are algorithm layer, kind of, sort of, from the utility section. And the database, the orange ones are the database layer, which is the backend or server-side programming layer. And yeah, and for the embedded devices, we will just add next to the storage the API calls, or the first one will be a web service. We will make a web service available, and then you can connect that web service step to whatever gateway and receive the data and send the data and then process the data with this family of steps there, graphically. And that means you can do any manipulation algorithmically as you want. And this is the main power of our tool, and I do believe that the Internet of Things will benefit from a visual tool that is able to even supply to other services this capability. Okay. Any questions? Yes?
Do you think there's a boundary where things get too complicated, such that they could be represented graphically, or do you think there's an arbitrary level of complexity that can that you can build using your graphical tools.
Graphically, you can, if you make the right steps, make it easier. You're talking about maybe of the Deutsch limit, right? How much information you can get in one line of code versus how much centimeters you need for one step. Is that what you're talking about?
Yeah, I mean, like, if I look at that picture, to me, it seems like really kind of hard to understand.
Yeah, well,
I think I generally agree that they can do a lot by, you know, aligning statements graphically. Like, you see that Scratch programming interface, which is like drag and drop and click together components that work in program later on.
but that's not programming. That's not a programming language. Why? The difference between configuration language, you know, configuring things, and programming, you know, it's a fine line. But there are three things. First of all, you have to have the power in order to express all three levels. And then what you do with the runtime errors. How does the programming language, for example, that you mentioned, Scratch, deal with runtime errors?
I think it doesn't, but
Exactly. And since it doesn't, doesn't deal with the runtime error, I cannot call it a programming language, right? Or how do you define programming language?
Well, it's a language that helps you express an order of things that happen that will eventually terminate.
Right. But everybody who's coding spends most of his time doing what? Debugging, right. So you have to be able to treat
Bugs.
errors. Right, runtime errors. So a language that proclaims to be a programming language and doesn't treat runtime errors is, for me, a configuration language. A language to configure things. That cannot be a programming language. Or, I mean, that's my personal point of view.
The thing I found very interesting when you have presented me your tool the first time was the possibility of monitoring what happens there and the red parts in your boxes.
Correct. Monitoring. Yes, that's the runtime. That's the runtime errors. Yes, correct.
Is there a possibility to create unit tests with you?
Yes, we actually have to use our own written unit tests in our own language because that's the easiest way to make unit tests for the graphical user interface for us. To write a unit test or a test for a graphical user interface interaction with another framework, trying to compose this flowchart is a challenge we haven't mastered, and therefore we decided to write our unit tests in our own language. Yeah. And this is a good point, by the way. The reason why visual programming what's wrong with my English now, never worked or never lived up to the promise they said we can do programming with this, is because in which of those diagrams or in which of those environments do you see a mechanism to deal with runtime errors? Because it doesn't matter how abstract I go, this is very abstract, yes? It's a very high abstraction level. It doesn't matter how high I go, I have to go down to machine code language. And machine code language is written in a fashion, or the whole architecture is written in a fashion that you have runtime error possibilities. And then there are those visual tools that generate code. And the best generators are very expensive. The problem with those things is when you have generated the code for a section of your program today, and then you generate the code for another section of the program tomorrow, and you run them together, you will be spending most of your time debugging again. That means you have to code again. And you don't, in our environment, you don't get any code, you never get to see code. Because as soon as you start seeing the code and you need to interface with it, you're back to coding again. And that is the biggest drawback of all the visual tools so far, including Dr. Resnick's MIT Scratch. Although his GUI and his features are great. That's really wonderful, yes? You see that his GUI is much easier to read than this one, because he doesn't define, we have logic flow, the black marks, data flow, and then we have some error handling too. Yeah? He doesn't have that. He just has snap-on, 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 and it's one line of execution. All the other tools, for example, the no-flow, for example, in California, is taking the data flow concept out of the 70s from a guy in Canada, and they are discussing with each other if it's okay to separate the logic flow and the data flow in the flow programming environment. That's philosophies, you know.